2.4, we're going to be looking at surveys and cardinal numbers. You know what cardinal numbers are. We've been talking about them. It's counting how many objects are in something. So we're going to be doing some counting techniques today. And this is the conclusion of our chapter, right? So it's going to kind of tie a lot of the things we've been working with into a single section, including Venn diagrams that we started last time. At least we did the bulk of last time. Okay, so the cardinal number formula is where we're going to begin. It tells you how to count numbers of things in unions and intersections, or at least it gives you a relationship between them. So the number of items in A union B is equal to the number of items in A plus the number of items in B minus the number of items in their intersection. I'm going to draw a tiny little Venn diagram up here to justify why it's subtraction at the end instead of maybe what you thought it might be if you had kind of looked ahead a little bit. Okay, there's my little diagram. All right, so what this says I'm going to do is I'm going to count everything inside of circle A. So right now I don't have anything in there. I'm just going to do shading. So we're going to kind of think about the space that's in there to sort of motivate why this is going to work for us. So the number of everything, or the circle A, is this going to be the yellow part, right? So if I count everything in the circle, whether it's in the overlapping piece or whether it's in the outside piece, and then if I were to count everything in the circle B, what happened to the middle? It was double counted, right? I counted it when I counted everything yellow, and I counted it when I counted everything red. It's double counted. That's why it's subtracted on the end off, is I'm removing the double counting. Okay, so like if you actually had, what we're going to be doing is we're going to be seeing numbers in these regions. And I know we did numbers in these regions last time, but the numbers we did last time were just placeholders, right? They were just allowing us to have a space in which to put something so that we can identify where in the picture we're talking about. The numbers we're going to be working with this time are going to represent a number of objects or elements within that area of my diagram. Okay? So if we knew the number of items in each of these individual areas, we wouldn't need to take away the part in the middle. What happens is that sometimes we know how many total items are in circle A and how many total items are in circle B, and somehow we've got to figure out what's in the middle or what's in the two combined, which means we need to know how many is in the middle. Okay, so that's where this formula is going to come in useful to us. Just in terms of identifying some pieces of the graph, we're going to take a look at this next one and see how it works where the numbers are already identified. So we don't need this cardinal number formula right here because we know the individual components they're given in the diagram. Okay, so we'll come back to this equation here in just a second. So taking a look at our diagram, it says we're going to use the numerals representing the cardinalities in the Venn diagram to give a cardinality of each specified set. So this says we want to do A intersect B. So looking at these is just like what we did last time. What number is in A intersect B? It's 6, okay? So we have 6 over here. How about A union B? What does union mean? We talked about it last time.
Everything.
Yeah, all the pieces, right? All the pieces that are in any part of the circle. And because they're actually individually identified, I don't need the formula, I just add the pieces that I see here. So I have a 3, 6, and 2, which gives me what? 11. You bet. Okay, so we talked last time about the fact that once we do complements, it gets a little bit more complicated. However, because this is 2 circles, we can probably reason through this without having to be super careful. And so this says, I want to know where A complement, which means the things that are not in A, and you can shade them if it helps. So what's not in A would be these numbers, right? These are the numbers that are not in A. And I need to know the numbers that are in B, because it says intersect B. So in B would be these 2 numbers, right? okay? And where do those shadings intersect? The two, right? I've got a mess on my screen because I've shaded them in, but right here is where they intersect, yeah? They were both shaded there. So this one would be a 2. I do the same thing on the next one. It says we've got A. Okay, well, the pieces that are in A are these two. And it says not in B. So not in B would be outside circle B, which would be here and here. Which one's got double shaded? Because it's intersection again. The 3 did. And the last one says not in A. Okay, so that's 2 and 7. And not in B. That's 3 and 7. And where do they intersect? At 7. Okay, so intersections aren't too bad to do by just piecing it together like we just did. Unions are a little bit trickier, which is what we saw more of happening last time. Now let me take a look with you at an example where that formula is going to come in handy, and I'm going to rewrite it at the top of my screen because it's not on my screen. It's on your paper at the very top, but not here. Okay, that's the formula from the previous slide. It says make use of an appropriate formula to answer the question asked. Okay, so the first reason that you should be using a formula is because it told you so, right? So they try to clue you in sometimes with the way that they've worded their directions. The other reason that you'll know that you need to use a formula is because they're asking about unions and intersections both within the problem, and that formula relates those two quantities together. So our formula that I just wrote down at the top, I'm going to rewrite at the bottom here, and we're going to be using it. So the pieces that we know, we fill in, and the pieces that we don't know are what we're going to find. It tells us the number of items in A is 8, so that's this one. In B is 14, that's this one. And the intersection is 5, so that's this one. So what that means is that I actually end up having everything that's on the right-hand side identified, and it's a very straightforward question to answer. But they can give us any 3 of these 4 pieces of information and we can solve for it. Okay, it's arithmetic, right? Adding and subtracting, that's all we're doing. So if they gave you the union part over here and they didn't give you A, that'd be okay. We'd still have 3 things we know and 1 we don't know, and we'd still be able to do that. This one, though, it is really nice. It's all on the right-hand side. So what is 8 plus 14? 22 minus 5? 17. So our value here is 17. Okay, so far so good? All right. All of what we're doing in this section is building up to problems 4 and 5. Number 3 has no context. Like, it doesn't tell you what any of these quantities or these sets are. We're just working with the computational pieces of it in this question so that we can actually use Venn diagrams when we get to 4 and 5 for some actual application problems. So on this one, it tells us we're going to make an appropriate Venn diagram using the given information to fill in the numbers of elements in each region. The first thing you probably need to figure out is how many overlapping circles do you need? So how many do we have? We have 3 on this one, right? There's an A and a B and a C all mentioned, so we're going to have 3 overlapping circles. Just like we had done before in the previous section, I'm going to label them just across the top like that, C at the bottom, and the universal set on the outside. Okay, so far so good? All right. Now, if we take the information as it's given to us, I'd like for you to see what's about to happen. It tells us that the number of elements that's in set A is equal to 24, right? Okay, diagram-wise, that's telling you that what's here, 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 and here all add up to 24. Okay, it's like a Sudoku puzzle. You got to put the numbers everywhere, right? And somehow we have to figure that out, but starting with the 24 and 4 different places that add up to it is not a good place to begin. Does that make sense? And for the very same reason, knowing that n of b is 24 or that n of c is 26 is not helpful. Okay, so we're not going to start with those 3 pieces of information. The next one says A intersect B is 10. Now that's a little bit better, but circle A intersects B here and here. Can you guys see that yellow okay? Is it? Okay, there's enough contrast, good. So while it's not as bad as 4 areas adding up to 24, I do need 2 areas to add up to 10. And that's still quite a few different ways that could happen, right? So if we can avoid it, and we always can, that's not where we're going to want to start either. So for the very same reason that we didn't really want to start with the n of A, n of B, and n of C, we really don't want to start with that middle row where it intersects 2 sets at a time. Because I still end up having to make a lot of guesses as to where to put things and checking things out, and it's going to be very tedious. Probably going to make a mistake, honestly. This one, however, is a very good place to start. A intersect B intersect C. Where is that? It's right in the middle. There's one place on the graph that does that, right? Yeah, so that's the one we're going to start with, which means that the number that goes in the middle is 6. Let me talk about what follows this on the listing of things. N of U. N of U does not mean the piece on the outside, because it kind of looks like that. N of U means the entire diagram of all 8 pieces. So we wouldn't want to start there either, okay? Just FYI. That said, now that I have the 6 in the middle, think about going back up here to this one. Now I have this portion of my graph adding up to 10, and I know one of the pieces is 6, right? So now it makes it easy to figure out that that one would have to be the 4. There's no more choices that I have to make. I simply am pushed into making the decision that that piece is 4. We can do the same thing with the next one. I have B and C is 8. So B and C would be this piece right here. I already have 6 there. How many more do I need? 2. Okay. The next one is here. A intersect C. So that's over here. 9, because I have to add up to 15. Okay. So it doesn't always like from the very inside out. Sometimes the information is presented a little bit differently. But it's going to be similar to this, where you're going to be working from one very specific case that they give you information about, someplace on the graph. Sometimes they'll say something like this. They'll say it in words, in a word problem. So there's a context or whatever, and it'll say, like, what's my context on the next one? Joe Long's writing and producing things. And it'll say he worked on something where he only wrote the pieces of music. So it'll identify that's in only the outside part of a circle. Sometimes it'll use the word only to differentiate that too. Okay, now we're back to the top line that we skipped, right, where the N of A is 24. Because now when I look at 24 and I look at this entire circle A, there's not 4 unknown pieces anymore. There's only 1 unknown piece. So we need to add up what we already have there. I have 9, 4, and 6. How many is that? 19. So how many more do I need for 24? 5. I usually kind of mark them off as I go. B is next. B is supposed to be 24 as well. So this particular piece down here is supposed to add up to 24. How many is there already with the 4, 6, and 2? 12. So how many more do I need? 12. And our last circle down here is supposed to add up to 26. I have 9, 6, and 2. 17. How many more? I need 9. Very good. Okay, so we're done with all these. Because I'm marking them off as I'm going, there's still one piece I don't have, and there's still one image on there that's missing a number. It's the outer rectangle, right? How am I going to figure out how much goes in the outer rectangle? You bet. So if you have a calculator to do it really quick, that's fine. If you want to do it in your head, that's fine too. We're going to add all these numbers in the circles together. Once you have it, somebody tell me what you got. 47 is what I was remembering. Yeah, it's 47. So how many do I still need in the outer box? 3. Okay, makes sense? All right, so now we're going to use this idea and we're going to actually apply it in the context of an application problem. And we are talking about Joe Long. So the ones that look like this don't draw the picture for you, and they don't identify A is this, B is this. You have to do all of those things. So it says, Joe Long writes and produces albums for musicians. Last year, he worked on 10 such projects. He wrote and produced 2 projects. He wrote a total of 5 projects, and he produced a total of 7 projects. And if you look on your paper, you've got some questions. Mine are on my next screen. Looks like this. It says, how many projects did he write but not produce? How many did he produce but not write? How many did he not write or produce? So we have to create the diagram in order to answer the questions. Is everybody tracking with me on that? Okay, so I'm going to create my diagram over here, and then I'll copy it over to the other one where I have my questions. The first thing we need to figure out is how many different descriptions of sets are we given here? 2. What are they, Addie?
Wrote and
Yes. So we have a description of writing the project. Whoops, good grief. There we go. And a description of producing a project. And if you want to give them the names, W and P or something like that, that would be fine. If you just want to write it out, that's fine too. So I'm going to write wrote, and I'll put prod for produce. Okay, so those are my circles. You can call yours whatever you'd like. Okay, of the 3 pieces of information above, actually there's 4 to be honest. I have 4 numbers here. I have 10, 2, 7, and 5. Which piece is it that's helpful or most helpful to start with? First one, well, the first one in the listing one, right? The bulleted list. Yeah, the number 2. Because of why? Yeah, it's almost like there's a key word in there. The key word's and, right? Wrote and produce, and for intersection, like we talked about last time. So that 2 is going to go in the middle, yeah? Okay. Now what?
Make it equal 7 on the produce side and 5 on the wrote side.
Excellent. So let's do one at a time. You mentioned the 7 one first, so I'll start there. Whoops. Highlighter. Over here, this is my produced category, and it says that he produced 7. So that does not mean I put a 7 in the outside circle. It means the whole circle has to add up to 7. So how many goes in the outer circle? 5. You got it. Okay. Same thing's true for the right circle. Well, it's the left circle, but I wrote the project circle as in right. Okay, so this one right over here. It's supposed to add up to 5, right? So how many do I need in the outside part of that one? 3. So what am I going to do with that 10? Doesn't go on the outside of the rectangle, but we do need something to go on the outside of the rectangle. It's going to be 0. Why is there going to be a 0 on the outside of the rectangle? Yeah, that 10 that they gave us is what all of the numbers added together are supposed to be. It's all the projects he's worked on. So in this case, I have a 0. That's okay. I can't have negatives, right? That doesn't make any sense. Cardinalities have to be whole numbers, but 0 is a whole number. It just means he didn't do anything else with the projects except these 2 different kinds of activities. This. Okay, so here's my diagram. According to my diagram then, how many projects did John Long write but he did not produce? 3. Produce but not write? 5. And then neither write nor produce? 0. So the questions themselves are really quick and easy to answer after we've done the work of creating the diagram. All right, here's our next one. At the University of Louisiana, half of the 48 mathematics majors were receiving federal financial aid as follows. 5 had Pell Grants, 14 were in college work study, 4 had TOPS scholarships, 2 had TOPS scholarships and were in work study, and those with Pell Grants had no other financial aid. Okay? Okay, issue number 1 for us to decide anytime we're given one of these word problems is how many circles am I drawing?
3.
It's 3. Okay? So I don't have a whole lot of space on this one, so I'm going to keep having to flip back and forth on this to get all my diagram drawn in. But yes, I'm going to have 3 circles. There's 1, 2, 3. And I'm going to label them the way they're described. So what are my 3 circles that I'm drawing for? Okay, Pell Grants. Whoops. Pell. What's next? Okay, so work study. And the TOPS scholarships. So I'm going to put TOPS. What's the whole box in this particular description? We didn't really talk about that on the last problem. It seemed kind of close.
It's 24. It's half of 48.
Okay, so the box is actually all the students we're talking about, right? In particular, over here, the mathematics majors that receive the federal financial aid. So kind of a combination of the 2 descriptions you guys are giving. So everything in this box are going to be a sum of 24, like the whole box, because in this box are all the people who are math majors with financial aid. I'll put FA. That's what the rectangle represents, and it is 24. Okay, we have quite a bit of information given to us, and we need to identify which pieces are most helpful for starting with. Any ideas?
The 5 Pell Grants and the 2 TOPS scholarships.
Okay, so let's start with the 5. Why would the 5 Pell Grants be useful for starting with?
Because you know it goes into one box because they don't have any other form of financial aid.
You're exactly right. Pell Grants has these 2 category descriptions, one that just tells you there's 5 of them, but also one down here that actually tells you that it doesn't really have anything in common with the rest of them. Nobody gets Pell in this scenario and something else, right? So the reality is that if you had wanted to, you could have drawn this picture. This is not my advice, but I'm just showing you that what it really is you could have drawn this picture with Pell Grants out here by itself. I mean, that would be an option. The other option is that you can actually make everything that overlaps zeros. And then we have our 5 on the outside. Okay, so either option is fine. So I don't want to go just straight to the TOPS one next, though. What might I want to do first? Yeah, the 2 that had TOPS and work study. So I have 2 with TOPS and work study. That's out here. Then I can go to TOPS. All right, how many had a TOPS scholarship? 4. So how many is going to go out in the TOPS outer circle? 2 more. Why is it 2 and not 4? It shares the 2 with the work study, right? The entire circle has to add up to 4. Okay, what's next then? Let's see, we've done this one and we've done this one. Work study, that's left, right? Okay, so 14 for work study. So what number do we need to put in the work study circle? 12, for the exact same reason, right? I need to remove the 2 that I've already counted for. All right, what am I missing? The big box number, the number that's in the outside area. The entire outside, or the entire box with everything in it, it's going to add up to 24. How many does it add up to right now? 21. So how many are left? 3. That's not always 3 in the outside box. It just was on our 2 examples, okay? Don't go trying to generalize that. Okay, you have to start with a specific piece that's been identified. In this case, it was the Pell Grant only part, right? And there's a bunch of zeros. It didn't happen to be the very middle piece. So then, how many of the 48 math majors had no federal aid? 24. Where did that 24 come from? The other 24 that didn't go in the box, right? That's actually why I had you label the box. The box is the 24 that had the aid. 24 others did not. That doesn't mean they didn't have scholarships. It just wasn't federal financial aid, the way that's being described. How many had more than one form of aid? Two. So whenever you see these phrases that say more than one, you're looking at all those overlapping regions. We only have one overlapping region with a number in it here. We got a bunch of zeros in the other places. So generally, you'd add up a bunch of numbers that are all in the middle there. But this one just has one of them, and it's just the number 2. How about federal aid other than these 3 forms? 3. That's the outside of my box. And then how about a TOPS scholarship or work study? 16. So when we see the word or, what does that remind us of? The union. It means I have to consider all of the places that include both, right? Either or, both. That's the 2 on the TOPS outside, the 2 in the overlap, and the 12 in the work study part. So I have 2 plus 2 plus 12, or 16. Any questions on that? Okay.